distinction between the prior probability and posterior probability, but it fails a bit short as a practical example in the real world. That is because the parameter k in the example is assumed to take only one value. Like in the last two examples, two topics, MLE and MAP, in both we estimated point estimation, like we estimated parameter as a single value. But in the case where parameters, space for the parameters takes an infinite number of possible values, a Bayesian must specify a prior probability density function. The meaning is, in the last we discussed like probability of parameter given x is equal to probability of x given parameter theta into probability of theta and evidence. Here we considered probability of x given theta. Here we are estimating the point value, like point estimate of theta parameter. So parameter we are considering a particular value. Okay. So here we are not estimating the distribution, we are estimating parameter. Okay. But what if we want to estimate, so instead of P means probability, P means a particular value. So in place of P, you write a distribution function. So F, G, H, G, these all are functions. Here P is probability. So probability gives a single value. Function, this is the PDF, probability density function. Okay, it gives infinite number of values. Okay, it is showing a function, it is showing a value. So, okay, if the parameter space, that is theta, takes infinite number of possible value, in that case, instead of computing this, we have to estimate the density function. Okay. So, understood the question, difference? Like MLE, we are maximizing this. MAP, we are maximizing this. But in Bayesian, considering all three, including denominator, we have to estimate the density function, not a particular probability, but we have to estimate the density function. So we are going one circle away beyond. The denominator evidence is, summation of all the components, like integration of, if you integrate the numerator from minus infinity to infinity, you will get the denominator. Means for each possible value of k, what is x? In discrete, this also can be written as a sigma of g of xi or sigma of x given I multiplied by probability of ki. So for each possible value of k, take the summation you will get gx in discrete case. In continuous value, you integrate from minus infinity to infinity, and the product of both you take the integration. This is also called marginal distribution of x, or the evidence, it is denominator. So in Bayesian estimation, we have to consider the denominator also. Not only numerator, but denominator also. Now let us have one. Let us consider the last example of flipping the coin. In fact, biased coin. Okay, it follows binomial distribution with n number of trials. So number of trials or number of outcomes, sorry, number of trials are n, and in n number of trials, number of head appeared r times. And consider the prior distribution, means our parameter k is not a constant, it is random value. So this k is also distributed as beta distribution with parameter a and b. So in the last example, we have seen MLE, then we applied MAP. Same example, I am continuing, considering denominator also. So the prior probability, that is the parameter k is distributed as beta distribution. So this is the form of beta distribution. Okay, gamma of a plus b, here a and b are shape parameters. Gamma of a, gamma function, how it is evaluated? For example, if I write compute gamma 5, how do you do? There is a property, gamma of x is equal to x minus 1, gamma of x minus 1. Okay, so it can be written as 4, gamma of 4. Again, gamma of 4 can be written as 3, gamma of 3. Gamma of 3 can be written as 2, gamma of 2. 2 can be written as 1, gamma 1. So gamma 1 is 1. So this is, you can say that for integral value of, if x is integer, then it is factorial of x minus 1. Like that. Gamma of x, it is integer, so it will be factorial of x minus 1. So the likelihood function is a binomial distribution. So NCR, a k number of head appeared r times, like head, tail, tail. So you have n number of outcomes. So head appeared r times, and 1 minus k, the probability of tail, were n minus r times n. So this is the likelihood function, a distribution of likelihood function. This is distribution of prior, and denominator is marginal distribution, that is likelihood multiplied by prior, integrating from minus infinity to infinity with respect to the parameter k. Now, this quantity, the quantity under blue circle is same in numerator and denominator. So it will be cancelled out. So it is free from k. So simply it will be removed. And k to the power r multiplied by k to the power a minus 1. So it will become k to the power a plus r minus 1. Similarly, 1 minus k to the power n multiplied by 1 minus k to the power b minus 1. So it will be, it is n minus r. So p plus n minus r minus 1. So it is numerator. Similarly, same is in denominator with multiplication. So this integration is about the k. So k is probability. So probability always belongs to 0 and 1. That's why the integration goes from 0 and 1. Now, if some quantity, like you have x, if you multiply by y and divide by y, so there is no change, right? If you multiply and divide by same quantity, there is no change. So here also, we shall multiply and divide by same quantity. We shall in the denominator. So multiply by a quantity, this one, and again you divide by the same quantity. Okay. Our purpose is to, I'll tell you later. So I'm multiplying by this quantity, dividing by same quantity. Similarly, okay, multiplying by this quantity and again dividing by this quantity. Okay. Fine. Now look at this one. Look at this quantity. This is a beta distribution. Like beta distribution looks like a gamma of a plus b divided by gamma of a gamma of b multiplied by k to the power a minus 1 and b to the 1 minus k to the power b minus 1. Now let us say in place of a, it is a plus r. Okay, in place of b, it is b minus b plus n minus r. Okay. So in place of a, it is n a plus r. So a plus r minus 1. In place of b, it is b plus n minus r. So b plus n minus r. So it is beta distribution with parameter a plus r, comma b plus n minus r. Now, so this is a probability beta distribution. Now, for any distribution fx, if fx is some PDF, probability density function, so if you integrate from minus infinity to infinity dx, it will be 1 because integration means cumulative probability. So cumulating all the probability will give 1. Okay. Like in normal distribution, we have seen that this area under curve from minus infinity to plus infinity, the area under curve is 1 because total sum of probability cannot be more than 1. So this quantity is integration from 0 to 1 because here beta is going from 0 to 1 only. So this quantity under the green rectangle will give you 1. So that is ignored. Now left out part is remaining. So this will go here. So finally, this is our posterior distribution. Now this posterior distribution again took a form of beta distribution. Again it is like beta distribution parameter with parameter a plus b uh, a plus b plus n, no, a plus b minus r with parameter a plus b minus r and a plus r. So the posterior distribution is also a beta distribution. So we estimated the distribution of posterior. Okay. So like in MLE, we only consider the likelihood. In MAP, we consider likelihood plus var. And in Bayesian, we have to consider denominator also. And instead of optimize it for point estimation, we have to estimate the var distribution itself. Our posterior distribution is this one. Now, once our posterior distribution is estimated, now we can find out point estimation. Okay. Okay. So Bayesians believe that everything you need to know about the parameter k that can be found in its posterior. So once posterior distribution is estimated, okay, we can estimate the point estimation of k also. For example, uh, just now we estimated the posterior. So what will be the expected value of posterior? What would be the expected value of k parameter? So expected value of k is equal to expected value of k given x, that is our function. So if you look at the beta distribution, so how to find beta mean of beta distribution I have not covered here, but mean of beta distribution is equal to this. If you have beta distribution among A and B, A plus B, if beta distribution is with parameter AB, then expected value of this distribution, that is mean of this distribution, is equal to A divided by A plus B. But what we have estimated in the last slide, our A was A plus R and B was A plus B minus M plus M. So A divided by A plus B, this is our expected value of K. So once posterior distribution is estimated, we can estimate any other point estimation also. So this I discussed one example for Bayesian distribution. Okay, we have some additional contents. You can go through that. Any queries? You ask. Is it audible to you? Hello?
Audible, sir.
Yeah. Any doubt on that? Vinita, Divya, ask the doubt. If people not asking any doubt.
Right now, no doubts, sir. Till now, the class is clear, sir. But there are so many, and like much more, we need to put pen and practice, sir. So after practicing, I guess we'll get doubts, sir.
Correct. So although I have put PPT there, but this 2-3 slides I have not included. I'll update the online PPT. You go through that. Okay, I try to understand. If you get any doubt, you ask. Okay.
Sure, sir.
So this way, if you look at the lecture plan, we completed Unit 2. Now from the next class, we shall move to Unit 3. Okay. Okay, fine. So, Mr. Khan, attendance already done?
Yes, sir. I already done, sir.
Okay, good. Okay, student, if you have doubt, anyone ask, or otherwise we shall close the session. So for the assignment 9 and 10, okay, I'll give you a separate quiz question so that you can submit the answers, whatever you will do or you have done. Okay. And regarding the mini project, the allocation is done, and let me today I'm going to share it with all the faculty members. So this section 1 is given to Uday Kumar. Section 2 is under me. Section 3 is under Okandar sir. Section 4, Chiranjeevi sir. Section 5, Kumar Anurupam. Section 6, Bhavanu madam. Is there any section 7 also? Anyway, I want to remind this section 2. Section 2 means yeah. Section 2 students I'll share this Excel sheet in our online classroom. You all have to put your project name. Let me just 1 minute. So, two mini project. Okay, I have to quickly share. Okay, so you will get a link for mini project here. Right, 2 times. Okay. You have to write here title of the project. Okay. Any student just try to access this. Are you able to open in edit mode? Sanmukh, are you there? Vinita?
Yes, sir. Checking.
Yes, sir.
Yeah, open it. Are you able to open in edit mode? Yes or no? Yeah. Yeah. Yeah, you're able to open it. Yes. So in this column, you have to write title of your project. Okay, Rohit. Have you decided your project till now? Team 1, have you decided the project? So in one team, 5, 6, 7 students are there. Okay, fine. So session is completed. CSC 1 student may leave. CFC 2 students, I'll take another 5 minutes regarding the mini project. Team 1, J, Uday, Kiran, Venkat, are you available now?